Okay, we're just going to keep working more examples of this because that's how you learn it. Try them out, do more examples, right? So we're going to integrate dx over 1 plus x squared, the quantity squared. What's the pattern? Well, first of all, can I u sub? Negatory, good buddy. So then if I can't u sub, what's the pattern? Tangent, because I have a number plus that squared. So a in this instance is just a 1. So this is just tangent theta. So this is secant squared theta d theta, because that's derivative of tangent, right? Okay, plug in everything you know. So now I'm integrating here with secant squared theta d theta, where the dx goes, and a 1 plus tangent squared theta, where the whole thing is squared. And remember back those Pythagorean identities. 1 plus tangent squared is equal to secant squared. Okay, so we have secant squared theta over secant squared theta squared, right? Because all I've done so far is just replace this 1 plus tangent squared with this secant squared. Now, I have 4 secants in the denominator, because power to a power you multiply, and 2 on top. So I'm going to take this, I'm going to go red on it, 2 of these, take out 2 of those, and I have 1 over secant squared. Well, what's another way to write 1 over secant squared? Yeah, cosine squared. Oops, not cosine 2, but cosine squared. But what do we know about cosine squared? Yep, always with those identities. So remember we did the power reducing identities. 1/2, 1 plus cosine, oh my, got a little crazy on that one. Cosine 2 theta, right? Same thing here. You can still power reduce what we already learned we're still using. Those identities work great. So I'm going to throw my 1/2 in front. And then we integrate. So I've got theta plus, and then the antiderivative of cosine is sine. But with that 2 on the inside, I have that 1/2 that's still there. Okay. Now I have this in terms of theta. But check this out. Double angle, right? Double angle. So when I have this double angle, let's introduce another identity. Just keeps coming, right? Good thing you memorized them back in trig. Sine 2 theta is 2 sine theta cosine theta, because I have to have plane theta to do my SOHCAHTOA with my right triangle. So we're going to replace our sine 2 theta. And we get theta plus 1/2 times 2 sine theta cosine theta plus c. 1/2 and 2 cancel out, right? Then I'm going to go ahead and just distribute this 1/2 that's here. Oops, let's go purple. Just so that we have it all out there in the open. So 1/2 theta plus a 1/2 sine theta cosine theta plus c. Now we do some right triangle trigonometry. This is theta, and oops, let me squeeze it back. And when you remember, x is equal to tangent of theta. So that's the same thing as x over 1. Tangent is TOA, opposite over adjacent. So opposite over adjacent. And you know, whenever you're looking at this, this is going to be the square root of x squared plus 1, or 1 plus x squared. Well, I'm going to squeeze it back in again. Sorry for all the back and forth. But here we are with the same thing. And it's always under that radical because the Pythagorean theorem, right, puts it underneath that radical. Okay. Now we come back down here to where we can see this better, and we work with it. We have a theta here. What what kind of trick do we do when we say, what is the angle measure? Normally we're saying sine of the angle, cosine of the angle, and I work within that angle, and that's where I get my SOHCAHTOA. But what if I have this angle already? Inverse trig. You guys are so good. Yes, inverse trig. And when you do it, because tangent is the one that I'm using in order to do the trig substitution, that is the inverse trig you have to use. Because it's a pattern you started with to even get theta, you have to do that same pattern. So this is 1/2 inverse tangent of theta, right? Okay. Is equal to, oh, pardon me, I put theta, for crying out loud, in a bucket. We're getting out of theta and going back to x. Dang it. 1/2 inverse tangent of x plus 1/2, and then sine, right? SOHCAHTOA, opposite over hypotenuse. And cosine, adjacent over hypotenuse, adjacent hypotenuse. And then it's an indefinite integral still. All right. You have to convert back. Now just clean this up a little bit. So I've got 1/2 inverse tangent of x plus, if I square something that is the square root, then those symbols cross out. And I'm left with x over 2 times x squared plus 1. And that's our final answer. You don't need to distribute the 2. If you do, great. If you don't, great. I don't care. Either way, it works there. All right? Okay. Okay, well, let's try some more.